Hello students, in the last class we talked about Ohm's law. We deduced the Ohm's law from the different formulae and we got the formula R is equal to rho L by A for resistance. Let us define resistance here. Resistance, if its English meaning will be taken, we can say it is the opposition. So this is the opposition offered by the conductor to the flow of charges through it, or to the flow of current through it, or to the flow of electrons through it. What is the cause of resistance? Whenever we apply some potential difference across the two ends of a conductor, what will happen? The electrons will get accelerated. We had seen the acceleration in the last class. Acceleration is equal to minus EE by m. This was the acceleration. The electrons will get accelerated and they will start moving. When they move, they will collide with the electrons and the positive ions. So this will be the opposition that will be offered by the conductor to the flow of current. There is not a straight path through which the electrons can move. They will again and again, they will face collisions, and hence this property will be there. This resistance is a physical quantity and the SI unit for resistance we had seen in the last class. It is ohm, denoted by a Greek symbol omega. It is ohm. Let us see here on what factors does the resistance depend. The factors affecting resistance. Let us go back to Ohm's law. In Ohm's law we had stated that keeping the physical conditions constant, physical conditions such as temperature, pressure, etc. applied on the wire. So if the temperature is kept constant, the factors on which the resistance will depend will be the length of the wire, L, directly proportional. Then resistance will be inversely proportional to the area of cross section of the wire. And the third factor on which the resistance will depend will be the nature of the material of the wire or nature of the material of the conductor. This will be, there is not any relation that R is directly proportional to rho. Actually this is a constant of proportionality. If we combine these two factors, we get R is proportional to L by A. And turning this proportionality into an equality, we can write rho L by A. So actually resistivity, it is the constant of proportionality. This is also called as specific resistance. From the formula, can we find the unit for resistivity? Let us see. Resistivity will be equal to RA by L. So, if we see the SI units, it will be ohm, meter square upon meter, and the SI unit for resistivity becomes ohm meter. R not only depends on this these were the L and A were the factors on which the resistance depends if the temperature is kept constant. But the resistance also depends on temperature. If the temperature changes, the resistance changes. The relation we can have is R is equal to R0 1 plus alpha T minus T naught. Now what is R here? R is the resistance at temperature T. R0 is the resistance at temperature T naught, which is some reference temperature lower than T. We can take it around 20 degrees Celsius or sometimes 0 degrees Celsius also. And this alpha, this is called as temperature coefficient of resistance. This formula can be written as 1 plus alpha T, where T is the temperature difference. Not only resistance, because resistance and resistivity are related, we can have a similar relation for resistivity. Resistivity at any temperature, it is equal to, where this alpha is again the same temperature coefficient of resistance. Now this temperature coefficient for metals or for conductors, this has a positive value. This means that when the temperature will increase, resistance increases, or we can say resistivity increases with the increase in temperature. But for certain materials, which we call as semiconductors, such as silicon, germanium, the value of alpha is negative. This means that as temperature increases, resistance decreases or resistivity decreases. Semiconductors are used to manufacture electronic circuits, electronic components, and this property is very useful, that their resistivity or resistance decreases as the temperature increases. And if we talk about alloys such as nichrome, manganese, they have alpha as very small. The value of temperature coefficient of resistance for alloys is very small. This means they can be used, since alpha is small, with change in temperature, the variation in resistance is very less. The variation in resistivity is extremely less. So they can be used to manufacture standard resistances or standard resistors. You can see the graphical representation. Let us draw graphs Let us plot a graph for copper. Let us plot temperature with resistivity. If we plot this graph, we will see that as temperature increases, the resistivity for copper